There's a few different ways we can solve a system of equations, but in this video, we're going to be talking about specifically solving a system of equations using the substitution method. Anytime you're solving a system of equations, no matter what method you're using, your goal is to figure out where do your two graphs cross. So when I'm solving a system of linear equations, what we're doing is we're saying, hey, I've got these couple graphs. One of them might look like this with a positive slope. Maybe the other one goes down like this and has a negative slope. When you're solving the system, what you're looking for is the point where these two intersect. So we're looking for the coordinates x and y of that point right there. Like I said, there's a few different ways to do this, but today we're going to be talking about specifically doing it with substitution. So let's go ahead and do this one. When you're solving with substitution, what you're saying is that you know what one of the variables is. So we're going to take that value, substitute it into the other equation, and that way you only have a single equation with a single variable and you can solve. When I look at the equations that I'm given, I see that x equals 7 minus y. So this 7 minus y, this is x. So what I could do is I could take that 7 minus y and put it in for x in the other equation, because 7 minus y is x. They're the same thing. They're interchangeable. So instead of x, I'm going to put that 7 minus y. So 2x minus 3y is equal to negative 11, but we know what x is. X is 7 minus y. So I go ahead and I put that in for x instead. And now I have a single equation with only one variable in it, and I can solve that. I simplify, of course, first by distributing, and then I combine my like terms, and then I solve. I'll subtract my 14 first. And then I divide. And I have found my y value. Now remember, we're looking for the point where the two lines cross. So the point is going to be an x value and a y value. So I'm going to take this y value, plug it back into one of my original equations, and then find my x value. It doesn't matter which equation you use, pick whichever one you like the most, but I'm going to go back up to that first equation, because in that first equation, we already know what x equals. X is 7 minus y. But if I already know what y equals, let's just put y in the y spot and solve for x. So x is actually going to be 7 minus 5. 7 minus 5 is 2. So now we have the x value and we have the y value, so we're done. So the solution to my system of equations is x is 2 and y is 5. And remember, what this represents is the point on your graph where your two lines cross. Let's do one more. So I'll take us through another one, but in this one, we don't have one of your variables already isolated. In that first equation, I've got 2x plus y is 5, and in that second equation, 3x minus 2y is 4. Neither of them are in the form x equals or y equals something. So I'm going to do that first, and then I'll be able to substitute. So what I'm looking for in both of these equations is which variable is going to be the easiest to isolate. So I'm looking for the one that has no coefficient, or a coefficient of positive 1. Positive 1 we don't usually write, so it's going to be the one that looks like it has no coefficient. When I look through my equations, I see that x has a coefficient of 2, so we're not going to use that one. This y has a coefficient of positive 1. There's no number written there, so that one's looking pretty easy. Here I have a positive 3 and a negative 2. So I'm going to go ahead and isolate the positive y in that first equation. So let me go ahead and take my first equation, 2x plus y equals 5, and I'm going to isolate y by subtracting the entire 2x term to the other side. Now that I know what x equals, I'm going to take that x value and plug it into my other equation. I can't go back to the first equation because this is the first equation. So I need to go back to the second equation. I'm going to go ahead and take this y value and put it in for y in that second equation. So 3x minus 2 times y is going to equal 4, but we know what y is. Y is negative 2x plus 5. So I throw that negative 2x plus 5 in for y, and then I simplify and solve. So I was able to find my x value. So now I have my x value, but I don't have my y value. So I'm going to take this x value and plug it back in to find y. We can plug it into any of our equations. So the one that looks the easiest to me is actually this one here that we kind of rewrote from our first equation. So I'm going to take x and plug it back into x in this equation to find y. So I found that y is 1, and my x value we already know is 2, so my ordered pair is going to be 2, 1, and this is the point where my two graphs cross. Hope that helped. Thanks so much for watching, and I'll see you next time. Bye.